To understand the functionality of reduceByKey, we have to see few more examples. To explain the power of map and flat map, primarily map, now we need to recollect the string manipulation functions, okay? And depending upon our input RDD, as long as we have to apply any row level transformations, leveraging the string manipulation functions which we have seen as part of Python programming, we should be able to apply transformations. So knowledge of the string manipulation plays a vital role to use the map functions effectively. Map function is nothing, you just have a RDD dot map, but the logic which goes to map is important. Okay, so for that I am creating a RDD called orders and using se.text file, okay, and then reading public retail db orders. Okay, now orders is of type RDD and each element in that RDD is of type string. And if you look at the sample data, you can say orders.first to get first record. It is nothing but a string. You can also preview by saying for I in orders.takeoff10 print of I. Now let's say I want to get for each and every input record like this, I want to get order status. How to do that? We need to apply split using comma as delimiter. It will convert into an array, and if you say that array of 3, it will give the order status. Similarly, if you want to get order date, you can say for each input record as part of map function, you can say split of comma of 1, which will give you the date, and then you can apply necessary logic to extract information further from it. For example, if you want to get only year, again you have to split and get the year part of it, or you have to use substring type of logic. Okay. Similarly, if you want to get order ID or order customer ID, which are of type integers, on top of the split and then index, using index on top of extracting this information, we also have to typecast to its original format using functions like int, float, whatever is its original format, we have to use the appropriate function and we have to take it from there. Okay. So let's see few examples so that you get a gist of it. Let's take the first example where I want to get order status for each and every input record. Okay. So first, for that, the better way to start is take this one string o equal to, put it in double quote. So we are creating a string variable o, and then I can say o dot split using comma as delimiter, which will convert into an array, and then I can say of 3. And then if you want to apply this as part of map function to extract order status for each and every record, what you have to do, you just have to say orders dot map, okay, lambda, you can give whatever variable you want. I am giving o, so that whatever I have explored here can be copy pasted, and then you can actually say take off 10. It will get the, okay, sorry, I have to use of 3. I missed this part. Okay, now you see you got only statuses. Okay, so similarly, if you want to get year, you can say o of split of 1, which will get us the date, and from that, year is always first 4 characters within the date, so I can say colon 4, which will get the year. Okay, but here year is represented as string, but it can be represented as integer also, so we should know how to typecast. So I can say int of like this, and now the data is even typecasted to integer. So this is how you can use map function and pass the logic as part of lambda function to extract the information you want. What are the real-time scenarios you can think of? For example, if your input record have social security number, and as part of your business requirements, you might have to extract only last 4 digits of number, and if you have to encrypt, you have to apply that encrypt function on top of extracting that last 4-digit number from the social security number. Similarly, if you have address in multiple fields, and if you have to consolidate into one field, you have to apply that necessary logic as part of lambda function in map. Also, if you want to standardize in such a way that no matter what case you get the input data for names, you might want to store it in uppercase in Hadoop or in downstream system. So as part of the map function, we can actually apply that case conversion rules so that data is stored as per the standard we define. So these are the business logics which we'll be implementing as part of map. Okay, so even though it sounds very simple, it is very important to think from real world perspective. After word count program, now let us talk about shuffling. So to demonstrate the groupByKey and reduceByKey syntactically, I'll be using order items data. Okay, and here I am using se.text file and reading public data from public retail db order underscore item. Now order items is of type RDD, and you can actually say order items dot first to get the first record. Okay, now let me define a problem statement. For that, let me preview several records, not just first one. I can say take off 10 print of I, and we can see the first 10 records. And let me define the fields here. Most of you are already familiar with this. The first field is order item ID. Second field is order ID, which is foreign key to order ID in orders. Third one is product ID, which is again foreign key to product ID in products. Fourth one is quantity, So how many items are being brought as an order item in this particular order? You can see that the product ID 502 is 5 of them are purchased in one order as part of one item. So there are 3 items with respect to order ID 2. Out of that, one item is with product ID 502 and the quantity of that product in that order item is 5. Okay. And then you have product price at the last field. The product of or the multiplication of the quantity with product price gives the order item subtotal. Now the problem statement is using this order ID, which is nothing but second field. I want to compute revenue for each order ID. So for 2, I have to add 199.99, 250, 129.99 and get the revenue for that order. For 4, I have to add 49.98, 299.95, 150, 199.92 to get the revenue for the order ID 4, so on and so forth. Okay, so here we will be again seeing usage of map. So in this case, map has to be used to convert each string. So there is one string which is of this format, right? And from this string, for each string like this, we have to get order ID. Order ID is nothing but 2, which is nothing but this second element after splitting by comma. And then we have to get subtotal so that the subtotals can be added using the order ID as key, which is nothing but 199.99. And for syntax purposes, if we have to use reduceByKey, we have to return these 2 values in tuple. Let me show you in the documentation so that you understand what I'm talking about. So here I'm going into the documentation, park.apache.org. The reason why I'm spending a bit of time on this is, if you recollect, when I actually explained in Scala, I didn't go through these core APIs, saying that it's not that important going forward. But I have seen that most of the projects still use Spark 1.6, and I felt that it makes sense for you to understand this also as much in detail as possible. That's why I'm reiterating this, and the same principles apply in Scala also. That's why I'm going a bit slow here. Okay, so now you can see here, as part of this programming guides, if you go to RDDs, accumulators and broadcast variables, and if you go to transformations here, and if you look at the syntax of reduceByKey, aggregateByKey, sortByKey, and also join, all these things expect your input data in tuple. Okay, so each element in the RDD has to be tuple. Tuple is nothing but unnamed object. In this case, it has to be paired tuple, which means there should be only 2 elements. Okay. So in this case, if I have to hold the first element as key and add the second element in these tuples, I have to convert the records in this input RDD, which is of type string, to tuples. Okay, and this can be done using map function. We are actually seeing one more functionality of map function where we are trying to convert the strings into tuples, and in that tuple, the first element is of type integer and second element is of type string. So again, I am creating a variable called OI and I'm copying this one. I'm just figuring out the logic. Okay, now I can say OI dot split comma, which will give the array, and to get order ID, I can say of1. To typecast into integer, I can say int of this one, and then you will get int of that value. Now along with this, I also want to get order item subtotal, okay, which is of type float, and hence I have to typecast. Now we have string OI, which is converted to tuple. So each and every string has to be converted like this. As part of map function, I can copy paste this logic and I can use it. So here I am saying order items map equal to, okay, order items dot map and then lambda OI, and then I can just copy paste this logic and hit enter. Now I can say for I in order items map dot take of 10 print of I, and you can see the values which are converted from strings to tuples. Now you can say order items dot count. It will have 172,198 records. As map generates a new RDD with same number of records, even order items map dot count will return 172,198 records. Once you have this paired RDD or RDD with elements of type tuples with exactly 2 elements, that is called as paired RDD in short. Once you have this, to compute the revenue for each key or to aggregate values for each key, we can either use groupByKey or reduceByKey or aggregateByKey. Okay, but if you go to the documentation, if you look at groupByKey, when called on a dataset kv pairs, returns a dataset of k comma I triple of v pairs. Okay, it doesn't perform aggregation directly. You have to follow up with another API to perform aggregation. And also it says if you are grouping in order to perform an aggregation such as sum or average for each key, using reduceByKey or aggregateByKey will yield much better performance. The reason is reduceByKey and aggregateByKey uses something called combiner, whereas groupByKey doesn't, and hence these perform better when it comes to aggregation. Okay, But syntactically, I will show you how we can use group by key for aggregation, but we shouldn't use. But it will help us to understand how group by key actually groups the data. If you look at this, if you want to convert data which is in this format, for example, there are 3 elements with respect to 2, right? If you want to convert into something like this, okay, so you have only key repeated once, which is 2, and then as part of value you have a list here, and that list contains all different values for that key. So if you want to convert your input collection which is in this format, so there are 3 elements with respect to 2 in input RDD in this example, and output RDD will have only 1 record for this, but that 1 record will have a tuple, and the first element of the tuple is the unique key, and the second element of the tuple is collection. Why do we need to do this? Either you want to add these things to get the aggregated revenue, or you might want to sort the data, or you might want to give the ranking to this data based upon certain criteria. As you want to group all the records related to the key and perform aggregations or ranking or sorting, group by key facilitate just to group the data like this, and after that you have to apply the necessary logic to get whatever you want to get. Okay, so in this case we are trying to get revenue for each order, and we will see how group by key can be used. So I am creating a variable called order items map gbk, stands for group by key, and I am saying order items dot group by key. It doesn't take any lambda function. We just have to say group by key and it will be grouped. Okay, now let us see order items map dot count. It has 172,198 records, whereas order items map gbk dot count will get lot lesser than that. Okay, let me see. Okay, there is something wrong with this. Okay, the reason why it is not working is I am applying group by key on order items, which is not correct. I have to apply on order items map. Okay, so order items map dot count have 172,198 records, and now order items map gbk dot count has 57,431 records. So on average for each order ID there are 3 records. And if you want to preview the data for I in order items map dot takeoff 10, first let us see from order items map, and you can see we have tuples. And if I say order items gbk, order items map gbk, the keys are unique. So there is only 1, 2 here, and the value is iterable. Iterable is nothing but collection. Okay. So as I have explained earlier, for each order such as 2, where there are multiple elements, is translated to 1 element in the output RDD, and the output RDD after group by key contains the key, and then all the values related to key will be translated to an array. As this is an array, let's say I create an array like this. Okay, so L equal to array. So if I want to add these values on top of collections, there is a function called sum, and the values can be added using sum. Now after grouping the data, if I want to get sum of order item subtotals which are already converted to arrays like this, what I can do, I can say, let me give the variable name as order revenue equal to order items map gbk. Okay, dot, typically group by key will be followed with map function as part of the map function, or sometimes it can be flat map also. When flat map will be used, we will actually see as part of advanced transformations which are nothing but ranking, etc. For now we will be using map. In this case, for each and every order ID I am trying to get revenue. Okay, so for each and every record like this, I want to add these values and return the revenue, and also along with this I want to get order ID also. So in this case, if I say lambda x or lambda o is of type tuple. Okay, so the group by key, after applying group by key, the data, the output RDD contains elements of type tuples only. So in this case, o is of type tuple, but the first element is in the tuple is nothing but simple key, whereas the second element is an array. Okay, if you just want to get keys, you can say o of 0. It will give us the key, but on top of the key I want to get sum of the values which are in the form of array, so I can say sum of O of 1. Okay, so now it will take care of returning a new RDD where each element will be nothing but key and some of the values associated with the key. That you can actually say validate by saying order revenue dot count order items map gbk dot count return 57,431, and this one also will return 57,431 because this is output of map. As I have mentioned to you earlier, the number of records in the output RDD after applying a map transformation or map API will be same as number of records in input RDD. And input RDD have 57,431 records. Output RDD also have 57,431 records. But input RDD have elements like this, whereas the output RDD for I in order revenue dot takeoff 10 print of I, you can see the key and the revenue for that key. Okay, so this is how syntactically you can use group by key and get the revenue for each order ID. Now the same thing if you want to use reduce by key and get it, as we have already seen, once we got order items map, let me get count first, and also let me preview the data for I in order items map dot take of 10 print of I, and you can see the results. Now using reduce by key, I just have to add this thing. So the logic is very simple. Syntactically, reduce by key is the simplest one out of group by key, aggregate by key, and reduce by key. So order items map dot reduce by key. Okay, let me create the variable order revenue rbk reduce by key equal to order items map dot reduce by key, and then you add. Either you can use add, which is imported from operator, or we can say lambda x comma y x plus y. Both these lines of code gives the same result. Now you can say order revenue rbk.count, it should return 57,431 records, and you can actually say for I in order revenue rbk.take of 10 print of I, and hit enter. Now you got the similar results or same results as we got after applying map, after applying some function as part of map after group by key with reduce by key. So when it comes to group by key, let me walk you through code with the group by key versus reduce by key. You can see that we have written 4 lines of code, and here it is only 3 lines of code with reduce by key. So it is simple to develop using reduce by key in case of aggregation. That is one advantage, and the main advantage is after group by key you have to apply map function again, whereas reduce by key the grouping is taken care automatically for you. The grouping and consolidating the information is automatically taken care for you, and also it will be taken care in much better way than group by key, and hence for aggregations we should be using reduce by key.